Alright guys, I'll give this like another minute for other people to join. And, I'm going to look at the computer most of the time to go through this. Alright, Nick, I think it's just you and me, so happy birthday, especially you. Okay, so I'm just going to pull up my computer screen and go through the problems today. So we're going to look at upper and lower sums. It's what we did yesterday, except for we're just not going to be as much detail. We're going to go through and take estimates. So let me redo my tripod here. See if I can try to get, nope, I will need a whiteboard, and see if I can kind of zoom in on this a little bit. Okay, so the first question is, okay, approximate the upper and lower sums of the shaded area for each function bounded by the graph. So we're looking at this part here from 0 to 4. Then use the upper and lower sums to estimate the exact answer. Use a width of 1 for your boxes. So what I'm going to do here is I'm going to start out left and right, and I'm going to just count up the boxes, like how high they would be. So I'm just going to make a list over here, left. I'll make another one right. And okay, so if I was going to start left bound from 0 to 4, first box I'm going to start, it has a height where 0 is. And if we look here, 0, oh, I'm getting a delivery. 0 goes up to 1. So our first box will be 1 over 1, so I'm just going to put a 1 down. Alright, next box, I'm going to start at 1, I'm going to go up, and like go over, just kind of visually in my head. I don't want to write on my computer screen. But okay, 1 goes up to 3, and so that box would be a 3 by 1, or has an area of 3. So first box had an area of 1, then the next box had an area of 3. Alright, next box, we're going to start at 2, and we'll go up. Okay, 2 goes up to 4, and that'd be a 4 by 1 box here. Alright, so I'll put 4 on our list. Alright, and then the last box, we're going to start at 3. I'm going to estimate that that goes up to about 4.5, so 4.5 by 1. So if I go ahead, I have here, left is 1 plus 3 plus 4 plus 4.5. And I'll just try to figure out what that total is. So that's 4, 8, 12.5. So if I did left bound area, I would say that is 12.5. Alright, now what we need to do is do right bound area. So right bound area means we're going to start on the right side of the function and work our way over. So if we're starting on the right side, I'm going to start with 4 and go up. Okay, 4 goes over to 5, and I'll go over. So 4, that's going to be a little bit above it. And so that'd be a 5 by 1 graph. So I'm going to put 5 here. Then we'll keep going over. Okay, the next box would start at 3. And what do we say? That was 4.5. And I'll go over 1. So that's a 4.5 by 1 box. Alright, then the next box we're going to start at 2. 2 goes up to 4, and so that'd be a rectangle that, that does come off. That's nice. 4 by 1 box. And then the last box here would be at 1. 1 starts up at 3, and we'll go over 1, so that'd be a 3 by 1. So our right bound function would be 5 plus 4.5 plus 4 plus 3. What's that total? 9.5 plus 7, 16.5. Okay. So there's no way to determine which one is going to be upper and lower until you get it done. And if we look here, left we got 12.5, right we got 16.5. So we could say that the area is guaranteed to be in between 12.5 and 16.5. All right. Then for the second question here is, okay, well, now just estimate. So if you had to estimate what the exact area of this function would be, well, pick a number between 12.5 and 16.5. And I have this set up as a range, so you pretty much can pick anything. So if I wanted to guess, okay, so let's say 14.5 was my estimation. That would work. So you can type in anything. If I wanted to say, okay, maybe 14.333, that should count it right because I have this answer saved as a range. Okay. Next question, or next two questions, are pretty much the exact same thing. So we'll just go through those again. We're going to use our boxes that have a width of 1. Now, if we wanted to get more accurate, we could make, the widths be like 1/2 or 1/4. But really, we're just estimating here. And so width of 1 is perfectly fine, especially since we don't know what the function exactly is. Okay, so I'm going to start on the left side. We're going from 1 to 5 here, so I'll start first with 1. 1 goes up to 4. So that's the first number I'm going to write on my list. Then go to 2. 2 goes up to 5. So that's the next number I'm going to write on my list. 3 goes up to 4. So I'm going to write that on my list. And then 4, which will be the last one, because once we make it a box as width wide, we'll stop at 5. 4 goes up to, we'll say 2. So our left bound region is 4 plus 5 plus 4 plus 2. Let's see, that would be 15. Okay. Now we got to do from the right side. So from the right side, we're going to start over here and work our way over. So, 5 starts out at 0. So that's going to be the first number on my list. The next one, 4, starts up at 2. So I'll put that on my list. And then 3 goes up to 4. So I'll put that next number on my list. And then 2, the last one we'll do, goes up to 5, because once we move over a box space, that would cover up the whole range, and that goes up to 5. So looking at our right bound numbers, our 4 boxes would be 0, 2, 4, and 5. And so we'll add those together. That would be 11. So once again, there's no way to tell which one's upper and which one's lower until you do both the left and right bound. But we can say here our area is going to be in between 15 and 11. And so that means the lower range is 11. The higher number is 15. And so in our answer, we'll put 11. And we'll put 15. And then the last question is just to estimate that area. Okay, so pick a number in between 11 and 15, and that should be good enough. So I'm going to pick the middle number there, 13. Now, if we want to put like 13.1, that should work as well. And that's pretty much it. So we use those rectangles that we did yesterday to help us approximate the area. And then eventually what we can do with them is make the limit of them go up to infinity, have an infinity number of boxes, and get the exact area. But that's further along down the road. Okay. We good? Oh, hey, Mallory just joined. Well, we just finished Mallory, so sorry we're a little late there. Pretty quick, though. All right, do you guys have any questions? If not, I'll end this video, and I'll post it to my story, and I'll post it to YouTube and Canvas as well. All right, I'm going to end this one. You guys have a great day. Only a couple more days left, maybe. All right, see ya.